Hello and welcome to honors function. In this short video, I'm going to apply the bisecting method to frame a zero of a polynomial. So what do you need for that? Well, you need a polynomial. So here we go. I took a polynomial of degree 3, p of x. Here's a question. Apply the bisecting method 5 times to find an interval containing the root of p. So my answer is an interval, okay? I will need to find an interval. It's going to be an open interval, actually, okay? All right, how do we do that? I'm giving you the first two boundaries that you have to look at, okay? So let's check out the value of this polynomial at -1 and at 0. So p of 0 is 2, okay? P of -1 is, so I'm going to change all the odds, and I'm going to keep the even. -1 plus 2, so this is negative. Therefore, I know there is a 0 between -1 and 0. So, let's apply the bisecting method once. I'm going to bisect this interval. I'm going to half it right here. And check out if my root is here or if it is there. So what is the next step once you have the interval? Well, you check where your solution will be. How do you check it out? You study the product, you look at the sign of the product of p at -0.5 times p at 0. It's okay if you take p at -0.5 times p at -1, okay? I'm just gonna take the right bound all the time. So what can happen right here? Well, two things can happen, right? This product may be positive, and if it is positive, I know my 0 is gonna be in, well, not in this one, so it's gonna be in the other, in -1, -0.5. And if it is negative, then I know my 0 will be in -0.5, 0. And then what? And then you continue. You're going to divide either this interval or this one in half, and you check out where the root is going to be, okay? And you do that 5 times. All right, let's keep track of our number of time. Number 1. So you will need a calculator, of course. I plugged in the function, the polynomial given into y1. So now I'm going on my home screen, and I'm going to type y1, so vars, y-vars, right here, y1 at, so this one is going to stay, so I'm going to put 0 right here. The other one I'll change. I won't do this vars, y-vars all the time, okay? So times y-vars, y-vars, y1, and here it's at -0.5. Okay, so, oops, it didn't take the 5.5 right here. All right, so let's press enter. And the sign is negative. Okay, the sign is negative. Therefore, my 0 is in, 0 in. So it is between -0.5 and 0. Okay, what's the middle in here? -0.25, right? Okay, so step number 2. I'm gonna check out the product of, so I'm going just to take this right here, and I'm going inside and I'm gonna type 2,5. Here we go. Let's check out the product. Ah, it is positive this time, okay? So, where's my root? Well, the root is not between 0 and -0.25. It is between -0.25 and -0.5. So I have a 0 in, so -0.5 and -0.25, okay? Because when I did p of 0 times p of -0.25, I had a positive product, no sign change. Therefore, the sign change must be in the other interval. Okay, so now I need the average between the two. So hey, I know what the average is, but if you don't know what the average is, you just do -0.5. Maybe I should have opened the parentheses, plus -0.25. Okay, I'm gonna put equal. I like to enter things in one single entry, divided by 2. and so it's negative 0.375. Okay, so what do we have? So we are between negative 0.5 and negative 0.25, and I'm gonna check the product right here. This is 0.375. All right, let's check out the product. So vars y1 at negative 0.375 times y vars y1 at negative 0.25. Okay, let's see this one. It is positive. Okay, so let's go back right here. This is positive, so the root has to be in here. All right. Okay, so step number three, my 0 is going to be between negative 0.5 and negative 0.375. Okay, let's divide that in two, right? I got negative 0.5 right here, negative 0.375 right here, and in the middle, what do you have? Okay, so I know it's all negative. Okay, so 0.5 plus 0.375 divided by 2. In the middle, I have 0.4375. So I have negative 0.4375, and I'm gonna test it in this one. That's my test right here. All right, so vars y vars, here we go, at, all right, let's see, we have negative 0.4375 right here times y vars y1 at negative 0.375. all right, so positive or negative, and it is positive again. So what does it mean? That means that my root is actually right here. So step number four, my root is in negative 0.5 and negative 0.4375. Okay, so I'm right here. I would need to do that one more step, but this is already too long, but I think you get the gist of it. You divide in two and you check out where the root is. Of course, you can check on your calculator if you're right or wrong. Let's do a zoom standard right here. Zoom standard, where's my function? Right here, here's my function. So the first thing I'm gonna do is shave off a lot of x min, x max right here. So window, I don't need all of this. I'm gonna go from negative 2 to 1, and I don't need all these y min, y max, negative 2 to 2 right here. Let's again check out the graph. It's gonna be a little bit clearer. Okay, and now I can ask my calculator to give me this root right here, okay, to give me this root to see if I was on the right track. So second calculate, it's a 0, so it's number 2, 0 right here. Left bound, is that the left bound on the root? Well, yeah, I'm on the left of the root right here, right? So I push enter. Right bound, am I on the right? Yep, I'm on the right. So let's see, and the root is 0.48, negative 0.48. And yep, I was in the right track right here. It's somewhere in between. Okay, again, we will need to go one step further. All right, so this is a problem you will have tomorrow on the quiz. Make sure you can do it quickly. Okay, this is not quick. Your calculator, what it just did right now, the way it found the root is not with this method. It could have been with this method, right? But it's a faster method that your calculator use, a faster algorithm. I talked to you about it in class already. Okay, the other thing that you will have tomorrow on the quiz is the approximation of n behavior, right? N behavior. So this is another formula that you need to know, and you need to be able to compute the percent relative error. So if I give you a polynomial p of x, if I give you a specific value x equals a, you should be able to tell me the percent relative error that you are making when you're computing the output of the polynomial or the output of its leading term. Okay, and I hope you understand what that means, and you have to be able to approximate that to give me the relative error. So it's always exact minus approximative divided by exact, and you put that in absolute value and you multiply by 100 because we need a percent relative error. Okay, and then apart from that, you will have the application of free fall motion. Okay, that's it. Thank you for watching.